Okay, I need to redo this sample problem. It was from lecture video 9.2, and I completely screwed it up the first time I did it. This is Dr. Montgomery, and this is for Gen Chem 1 at VVC. Section 9.2 of Chapter 9 in your online book. I don't know exactly where I got this problem from, but probably said in the first video. Anyway, this is the problem that I'm working on. It's a 50-gram sample of metal initially at 98 degrees Celsius is placed into 99.85 grams of water. The water is initially at 25.2 degrees Celsius. So we have hot metal dumped into room temperature water, and the water heats up. The final temperature of both the metal and the water is then 32.3 degrees C, and we want to know what's the specific heat of the metal. So what we're going to do is, first of all, I'm going to change the color of my pen. So I was working in blue and green. And so what we're looking for is the specific heat of the metal. So we want to know C metal. And that's going to be the Q of the metal divided by the mass of the metal and the delta T of the metal. So we know the mass of the metal and we know the delta T of the metal. And while I'm doing it, let's go ahead and just explicitly write down the delta T for a metal, because I messed it up on the first video. So the final temperature of the metal is the same as the final temperature of the water, which is 32.3 degrees Celsius. And the initial temperature of the metal was 98.0 degrees Celsius. So the difference here is going to be a negative T. And let me just grab my calculator. We're going to have 32.3 minus 98, which is negative 65.7. So that was one mistake that I made on the first video I did, was I calculated the delta T wrong. And we know the mass of the metal. So the mass of the metal is given, and it's 50.0 grams. So we need to figure out the Q of the metal. This is the value that we are looking for in order to complete this equation. Well, the Q of the metal is going to be the negative Q of the water. So we want to find Q of the water, and that's going to be equal to the mass of the water times the specific heat capacity of the water times the delta T of the water. And so the delta T of the water is going to be the final temperature, 32.3, minus the initial temperature, 25.2. And that is equal to 7.1 degrees C. And so in the problem, I forgot to multiply that value by the mass and the specific heat capacity, so I got a totally wrong number for the for the heat of the water. We need to multiply 7.1 times the mass of the water, which is 99.85 grams. And the specific heat of the water is 4.184 joules per gram degrees C, and then the delta T of the water is 7.1. Let's see if I can put these numbers in the calculator correctly this time. 99.85 times 4.184 times 7.1. We get 2,966 joules. So my Q of the water is equal to 2,966 joules. And then the Q of the metal is equal to the negative Q of the water, which is negative 2,966 joules. So to calculate my specific heat capacity of the metal, I'm going to substitute these values in, negative 2,966 joules divided by 50 grams and negative 65.7 degrees C. And so that number change the sign on this. We're going to divide it by 50. and then divide by negative 65.7. And so I get 0.903 joules per gram degree C. There we go. I think I fixed it. Sorry about that. And thank you to those of you who pointed it out to me, one particular person. I appreciate it when you guys let me know the mistakes. It's really important that I correct those. So anytime I make a mistake, please don't hesitate to just let me know. All right, bye for now.